and welcome to the Signal Pad. Today I have something different for you guys. Normally we work on microwave instruments, repairs and reviews and so on, and I was working on this little project for myself and I thought, why don't I share it with you guys in case you want to make one for yourself, considering how useful it might be. Now, as you can see, this is a picture frame with an Epaper display on it. This is a 7.5-inch display. It's now come down in cost significantly. This is a 3-color version. It has white, black, and red. So the 3 colors can be programmed directly from the interface, and you can show some interesting things like what I'm showing here. This is also connected to the internet, and it grabs information from the net. It knows what the date is and shows you the current calendar. It shows you the weather that is happening now and the weather that you would be expecting for the rest of the day. It also grabs a list of tasks which you have from a website directly from the internet and populates them. And because it has 3 colors, you can then use those at your advantage in displaying some of the things that just a black and white one cannot do. For example, if you have lists which are past due, they will show up in red. If your list is longer than what can be displayed, you will get a little warning in here that there's more that's not being shown. And I'm also showing a picture of a little cat and a heart so you can see how you can import bitmaps directly onto it. And the last time it was updated also shows up here. Now, because this update is really slow, it takes about 30 seconds or so to update this. I'll talk in details about exactly what's going on with these displays and how they work and how some other people have looked at these into detail and see if they can be even sped up. Now, I haven't tried to do this speeding up of the refresh and local refreshing of this, because by default local refreshing and partial refreshing of this Epaper is not enabled by the firmware that comes directly from the vendor. But nonetheless, the fact that this is connected to the internet and can grab the data from the internet can be extremely useful. And it has some other interesting features as well, and I'll show you how it works. Let's turn it around and see what's in the back of the frame. Now, there are many ways to run these frames. You don't have to run them the way I'm doing it, but I have it actually connected to a Raspberry Pi Zero. So you can see the Raspberry Pi Zero over here, and there is an attachment, I think they're called hats, which sits directly on top of the Raspberry Zero, and it connects to all the 40-pin header that is available on the unit and can extract information directly from that. Now, these displays run from SPI interface, and I believe right now it's set to a 4-wire SPI interface, and there is a little connector in the back which allows you to relieve some stress and strain from the cable that's directly connected to the display, and a little daughter board that gives you a much longer ribbon cable so you can mount that anywhere you want. But this is really all that is needed. Once it's programmed and you write your software, you can just connect the Raspberry Pi to a power source, and then it hooks up to your Wi-Fi, and then it's a completely standalone unit. And when it boots up, it automatically runs the software which is responsible for doing all this updating. Now, one of the advantages of using a Raspberry Pi in this case is that you can run Python very easily on it, and of course Python has a huge wealth of libraries available which you can use to grab information from the net and do all kind of fancy programming directly in Python language. And it's a little slow, Raspberry Pi Zero, but once you develop your code and you leave it running, then it works perfectly fine. And here is your other option for driving this board. I like this module too. There's an Epaper ESP8266. Of course, the ESP8266 is quite popular, and you can program this. This can be completely standalone on its own, by itself, because of the microprocessor that's in there, and you can hook up to Wi-Fi and do all kind of Arduino programming. If you use something like this, the power consumption of the full system becomes significantly smaller, and you can put this into deep sleep mode and so on. And since the display will retain the content, you can just wake it up, update it, put it back to sleep, and it can be battery powered for maybe months or even years, depending on the kind of battery you use and how efficient you can program this when you write the code for it. So for ultra efficiency and so on, definitely this is more interesting. So how does this Epaper display actually work? Now, thanks to some of the research that other people have done, we can explain exactly how it works and then look at it under the microscope. So it's made of a lot of these honeycomb patterns, and these honeycomb patterns are full of charged particle of ink colors that can move around inside the viscous fluid. So you can imagine it being full of little charged particles that are everywhere, and then you're looking at the surface of this honeycomb from above. There's an electrode on top of the honeycomb and an electrode underneath the honeycomb. An electrode is thin enough that you can see through it. So you can imagine that by applying a charge above and below these honeycomb patterns, you would be able to move these charged particles up or down. Now, it's a lot more complicated than that, because if you just apply a DC voltage to those electrodes, you can store charge on the display itself, in which case then you will lose the ability to move these particles around after some time. So some clever AC voltages have to be applied in order to move these particles around inside the honeycomb. Now this honeycomb is also filled with a viscous liquid, some kind of an oil-like liquid, and this viscosity of this liquid allows these particles to move slowly up and down, and when the charge is not applied, they're at perfect buoyancy to stay exactly where they are. So it's a pretty complicated structure. But once you add color to it, things become even more complicated still. So imagine that we look at this now from the side view. So you have the honeycomb sliced, and then here's the top of the honeycomb, here's the bottom of the honeycomb, and these are where the individual electrodes would be. And this is now filled with these charged particles. Now imagine that the black ones are all positively charged, and they're kind of floating all over the place. And the white ones are negatively charged, and they're kind of all sitting at the bottom. If you were to look at the honeycomb from above, what you would see in this case is that you would see a black pixel essentially, because all the dark particles are at the top and the white ones are at the bottom. Now if I apply a cleverly designed waveform to the top and the bottom electrodes such that I don't polarize the display, but at the same time I move the charges, I'm able to bring these negative charges to the top and bring these positive charges to the bottom, changing the color of the pixel. And that way then the pixel would look like a color white. But then if I add another degree of complexity to it and add these positively charged red dots in there, which are now much larger physically than the black ones, I can now do something even more clever. I can first bring the black particles all the way to the top, and they will move faster through the viscous fluid because they are smaller. And the larger particles also want to go to the top, but because they're moving slowly, they will not make it to the surface of the honeycomb, and the black particles will all gather up at the top, blocking all the red ones from being visible from the top. And then what I can do is I can flip the direction of the electrode charge, and then at that moment the black particles want to come down and the white particles want to come up, but in that moment the red ones will make it to the top before the white ones can make it to the top. So if I can time that carefully, I can bring the red particles to the surface of the honeycomb and turn that pixel into a red color. And then if I want to turn it into a white color again, I just continue that waveform until all the white ones wiggle their way up and they come to the surface of the honeycomb. And this process can be continued. So this tells us a couple of really interesting things. It means that it is impossible to get a pixel to turn red before making it turn black. And that's exactly what we see when the Epaper is running. First it turns black, and then the areas which you have chosen for it to turn into red turn red. The controller that controls all these honeycomb pattern electrodes are being applied and the waveforms being applied and how much voltage is applied and how long the voltage is there, all of that is controlled by a series of hexadecimal numbers that are written into the firmware controller, and that's what applied science has played around with in order to change the speed for which it can be refreshed, and more importantly to get partial refresh on the display that's not natively supporting it. So I definitely encourage you to go and look at his work, and I haven't done that here but in this video, but I think it would be really cool to do the same thing on the one I have. I want to focus on the Python code and tell you how you can program it and get some fancy things being displayed on it to make it more usable for the kind of things that I want to use. But if you get partial refresh, definitely let me know because I want to try that as well. So now having said this, I think it's a good time to go and take a look at the Python and also to take a look at what happens when it's actually refreshing, and hopefully we can get a nice view of it under the microscope and seeing these honeycombs change color under the microscope. So let's start with the Python code. So let's take a look at this Python code that I have written here so you can get an idea of all the functionality that it has, and once I explain it to you once, you'll get you hopefully up to date so you can modify it for your own needs. Now at the very beginning of the code is going to have some initialization and bringing some of the packages required for all the other functions in the code to operate. The most important here is the very first package, the EPD 7.5-inch B. That's the file generated and provided by Waveshare that has all the functions to update and manipulate how the Epaper interacts through the SPI with, in this particular case, using the Raspberry Pi Zero. So all the functions are written in there. Image, image draw, image font, and all the other imports that you see are for manipulating images, drawing things, for putting fonts on the display, creating images, getting and manipulating times and calendar events, and all of those things are very useful, of course. Now, request and JSON are used to interact with APIs online. So the different websites that I'm going to talk to get my to-do list and to get the weather are going to use the request package, and the JSON package is going to interpret the data generated by those APIs so we can extract information from this large chunk of data that it returns. Want is going to be used to display images, as we shall see. So after that, we have a screen resolution 640 by 384, and then there is two tokens and APIs here which you need. On the to-do IST website, there you can register and create your own list of to-do things, and you can manipulate them and put deadlines, and that gives you an API. And that this token is unique to your account, which you need, of course, to interact with it. So there's no username and password. That API code is unique. It's a large hexadecimal number. The reason I don't have it here is because that's connected to my account, so you have to get your own. Same as the weather API. Both of those are free, so you can easily get them. And you'll see the websites. I'll show you that in just a second. Now there's a debug mode variable here, and this allows you to put it into debug mode by putting a 1 there, and then it won't interact with the ePaper at all. It will just generate an image that it would have written to the ePaper. It's much faster for debugging your code to do that than having to update the ePaper each time you make a change to the code. And this just tells you that the ePaper needs to be updated. This is used in a loop, and you'll see how that works. So here we initialize the ePaper here using the importing the package that's given by Waveshare, and if it's in debug mode, if it's not in debug mode, we go through the complete initialization. Otherwise we don't do that, and if it is, then we just say that yes, we're in debug mode. And there's a couple of global variables here, and these global variables are things like the to-do response, and things like the calendar width, the line start. These are all variables that tell you where the drawings of different things start on the screen. And I've made them global because it's a lot easier for different functions to access them. I'm sure this code can be optimized, but for just something that's been thrown together, it works quite nicely. Now here I define all of the fonts that are used throughout this entire display. Now there's quite a few of them, and as you can imagine, didn't want to do that. So there's a lot of different fonts, for displaying different things. Obviously the date shows up much larger, and then the day of the week and the month and the calendar font and the task fonts. These are all different things. So I'm using a whole bunch of different kinds of fonts that are all freely available. I'm using all of those. And one of them is special. The one that's special is this one. This particular one is a font, a TrueType font that has symbols of different weather conditions, sunny, cloudy, rain, and thunderstorm. And that's very useful because you can directly draw the symbol that is associated with the weather. It would be an icon of the weather. So that is a freely available one. It kind of looks like this. It just means that in this particular font, if you try to type the letter A, you're going to get this sunny symbol. If you try to type the letter C, you get this one. So there's a one-to-one interpretation between the Unicode that is given underneath it and the image itself. This makes it very easy to extract information from the API handler, find out what the weather condition is, and use the symbol for the icon and then display that on the ePaper, as opposed to having to manipulate many bitmap files. Very useful to do this type of thing directly in the font because it's in line with everything else we're typing on the screen. So that makes it very nice and easy to work with. This is free, available online. That's how I downloaded it. And here, this icon list is a list of conversion between the value the API returns online and the letter corresponding to that icon. So if you go to the website for the weather, I'll show you that. On that website, there's full instructions, and they tell you if I return the icon value of 01D, that means that it's going to be the weather represented by the letter B. So it's going to be this one. It's going to be a little moon shape. So now you know what corresponds to what. So this is how I'm able to extract different characters directly from the weather icon and display them on the screen. So you can take a look and see how that is done. This just sets the first date of the day of the week. And here, the rest of this little section here allows me to do things. It's continuously running forever. So every 1 minute, you can set that variable here. Every 1 minute, it checks to see if your to-do list has changed. And then if it has changed, it will update the ePaper. But if it hasn't changed, it will not update the ePaper because there is no need to keep refreshing the screen if nothing's changing. But every 10 minutes it's going to update in case the weather has changed, and in case you're rolling over midnight and the next day is starting. You can change these variables. You can change the variables and put whatever you want there. If you want to make them longer, make them longer. I suggest not to do this every 60 seconds because you eventually get your maximum quota of the number of times you're allowed to communicate with the to-do website. So then you have to adjust, and there are some exceptions you have to catch because of that. So this is something I would recommend changing maybe every 5 minutes here and every 15 minutes to change this one, but it's up to you. And this is just simply calculates when to do each of those things. If the timer has run out and you have to update this screen or not, and this just takes care of that. Now, there is this function over here. This function queries the to-do list. This whole function's job is just to simply communicate with the API online, grab the data from to-do lists from a website, and then extract the data from it and pass it to the next function. So it might generate some exceptions, and sometimes it returns the wrong values, and if you don't catch those exceptions, the whole code will crash. So these exceptions simply catch those errors, and you can see it will print out what went wrong. And here, if the response that the website gives you is not the response that it gave you last time, it means your to-do list has been updated. And then it tells you, okay, the task list has changed, and it's going to set the flag for screen update to 1, and then next time the code runs, it will update this screen. Same thing with querying the weather. Here you can see that I'm checking the weather. Not only am I checking the current weather, which is the weather here, I'm also checking the forecast. I'm getting both of those data out so that I can plot the current weather and how the weather will be later during the day or tomorrow. It's up to you. The data that it returns is massive. Just to give you an idea what those websites actually look like. So here is the website for the open weather. I have a JSON interpreter built into Chrome, and it tells you all the kind of data that this will return to you. So you can see that this is a JSON packaged database that is returned, and you can see under list, under main, it tells you what the temperature is, it tells you what the main weather is, and it tells you what the icon ID is. And this icon ID is what I map onto those letters that ultimately change the symbol of the weathers. That's how this interpretation is done, and this keeps on going on, and there's many items and different. This is for the forecast, so it tells you that it's going to be cloudy, and it tells you that this is a time where this is going to be cloudy. So you can grab as far as you want. It just keeps going. I think it goes as far as 3 or 4 days, or maybe even 7 days. Here we go. It goes all the way to the, it says 5-day forecast or so. So you can grab as many of them as you want and grab the data that you want that's important to you and show only that. But there's a JSON interpreter for Chrome. It's all free. You can get that. And here's the website for the to-do list. You can see here's all the lists that you saw show up on Epaper. I have just typed them over here. You can set your due date. You can set things like how important they are. All of these things can be really easily set, and it just grabs all that information and then reinterprets them for the Epaper. So you can see how easy this is actually to put together. It's remarkable that you can do this with so little code, because all the hard work has been done by the people who have written the APIs and by the servers and all the communication that's available to grab this data. And then there's the refresh the screen. Now, in refreshing the screen is where all the drawing of all the letters and boxes and lines happens. And some of these are going to be depending on each other, because if the length of the strings change, then you have to center them. So the word Saturday and the word Monday don't have the same number of letters. So you have to center those depending on how wide that whole text will be, depending on the string that's actually in there. So that's some of those computation is done here. First, we start with two images, bkblack.bitmap and bkred.bitmap. These two files, let me see if I have them available here so I can show you. These two files are simply going to have, let me see if I can show you what that looks like. There it is. Just one of them is just simply the picture of this cat, and the other one is the picture of the little heart. So the black image is going to show up with this one, and the red image is going to show up with this one. That's how you can separate the frames from each other, which means that throughout the code, you're actually creating two separate frames of data, one for the red and one for the black. And once you create that, then you can manipulate them individually, and they will then show up separately. So for example, we start by grabbing all the strings for what is the day, what is the date number, what is the month, calendar, what moment was the update done. All these data are being grabbed from the time package. Here I'm computing how to center the different text of date and month and week and all those things, and all of these things are done over here. And in front of each of these lines, I have written exactly what is being drawn. Some of these are written with absolute numbers. It's not really a good way to write code. You want to write code always with reference to a point that is fixed, so that if you have to stretch things or if you change the resolution of the screen, everything will stretch with it. But anyway, for our purposes, it doesn't matter. So all that code is is over here. And then after this, here is where I query the weather, and you can see how I can grab the different parts of the JSON handle. So this tells you, okay, the weather response, go to the weather section from the 0th position of the array, from the main position within that sub array, tell me what the current weather is, and that's exactly what this will return. So this will say rainy, cloudy, or whatever. And here's I extract all the temperature. The temperatures are in absolute Kelvin, which is kind of funny. And so then you subtract that from 273 to get the Celsius. Now I'm showing everything here in Celsius. And everything else is pretty explanatory. I've written everything in front of it. So for example, it tells you this is the text of the current temperature. This is where I calculate the size of the different text that needs to be there. So everything moves accordingly. Things always line up. Things always look nice and centered in the screen. That's what all of this computation simply does. After that, we get to the part where we have to create a to-do list. And here in the to-do list, we just go through every single item in the to-do list that's captured by the JSON handler. And if they're too long, we shorten them. And here we calculate that is there what is the current date of the year. If there is a due date that you've set for a task, this is where we check what that date is. And if the due date has passed, then we assign the red frame to be the frame we are manipulating. And if the due date has not been passed, then we just assign the black frame to be the frame we are manipulating. And that's how I create the red and the black version of the to-do list, depending on the due date, whether it's passed or not. And the rest is just drawing the line and the little symbol that tells you the priority and the text of the task. All of that is also pretty straightforward. And if you end up getting too many items that goes beyond the screen, this detects that and it stops the loop from running, and it just adds ... and the number of items left plus more, so that little symbol shows up at the bottom telling you that there's more tasks that are actually not displayed. And over here, if you're in debug mode, then it will generate images and actually save those PNG images for you, so that you can look at those PNG images and it pops on the screen so you can read them directly. Otherwise, it will begin updating the Epaper, and we're using the EPD function to do that. And the function is really straightforward. All you need to do is to get the frame from the black image and get the frame from the red image and pass it to the function, and it will do everything else for you. And if you're in debug mode, you will get two images. One would be the black frame. So here's an example. This is what the black frame, for example, looks like here. You can see everything that would show up black is here, and then everything that would show up red is here. So the little part at the bottom that says more tasks are left, the whole task bar, everything that has past due date and the little heart, these are in red, and everything else is in black. So the code is really pretty straightforward from that point of view. Everything has been commented as much as I could, and maybe I'll add some more comments before I distribute this, and I will package all of this, including the font and including all the libraries you need, and I will put that on the website, so you can just go and directly grab it, and I will put a list of all the items that you need to buy in order to make this project for yourself. So let's run the code and see how it looks like and how long it takes to update. So I'm running the code right now. There we go. There it is. So you can see first it reverses all the colors and moves all the inks in the opposite direction. Then it flashes it over and over again, bringing all the white particles to the surface until it is completely clear. And then once it's done that, then it brings the blacks to the top. There it is. So you can see now everything looks black, even the parts that are supposed to be red. And now it's doing more on the parts that are supposed to be red and bringing all the red particles up. And it should be done any second now. And it's still doing it. There it is, and it's finished. So it's back to what it should look like, and of course it has all the latest information on it and the date and the time that it was updated. So this is what it looks like. But I want to go ahead and maybe look at it with a microscope somewhere very close to here, and perhaps somewhere where we can have both colors at the same time next to each other, so we can see how it looks like as it changes color. So let's go and give that a try. Here's the screen under the microscope, so you can very clearly see the honeycomb pattern, and this is supposed to be all the three colors. So at the bottom we have white, in the middle we have black, and at the top we have red. Now even though this is supposed to be completely black, I'm shining light on it and you can see some of the red particles from underneath the black still visible. So I'm going to refresh the screen and see how the cycle looks under the microscope as different events take place. As it gets clear, then the image gets inverted, and then the black will emerge, and ultimately the red will come up. Here we go. So here's the white, and you can see first right now the image is inverted, so everything that used to be black is now white, and now the whole screen is going to be refreshing. and you can kind of see some of the red particles still visible, so it can't deplete it completely very well. So it's clear in the screen now, and soon just the black will show up. There it is, there's the black ones, there it is, and now after that the red ones are slowly merging. So you can see how it works. It really does go through all that cycle, and then eventually it's going to stop, and once it stops there will be no more flickering. There it is, and all the red ones are now attracted. Alright, and I hope you enjoyed this little project. It's a little different from the kind of things I normally post, but it is nonetheless a neat little thing to have on your desk, and it's quite useful. Definitely a conversation piece. So let me know in the comment section what you think about it. As always, feel free to subscribe and leave a comment in the videos. It helps, feedback is useful, and it allows the video to reach a bigger audience. And all the code and all the parts and everything you need is all available in the comment section, so you can download it, play around with it. I have a Twitter account at the Signal Path. Let's send some photos to me if you make one of these for yourself. Give me some ideas of what to put down here and how you would think this should be changed so that other people can also benefit. To my Patreon supporters, you guys are amazing to see the support that you have, and there's going to be some great stuff for you guys coming up. Just be a little bit more patient. It's going to happen anytime now. And I'll see you next time. I hope you like this one.